Assalamualaikum warahmatullahi wabarakatuh. My name is Hide Masashi Rakawa from 10 USB, and today we have a physics equation to finish. And where is the question, you may ask? Well, it's right over here. Why does it appear down there? Hold on for a second. I'll make it bigger for all of you to see. And there it is. So, given in the question, it is obviously talking about torque, which is basically like a circular momentum, if you may want to know. The P over here, hold on for a second, the P over here, that is the pivot. These are the force, this is one of the distance, and this is the only angle in this equation. Why is it there, you may ask? Well, you will know soon enough. So let us see at the choices first. T1, this is torque 1. This is obviously referring to the force 1. Torque 2 for force 2, torque 3 for force 3, and torque 4 for force 4. I may accidentally made a rhyme over there. Anywho, it obviously wants us to find the torque for these points in the pivots, 25 centimeter from the pivots, 25 plus 25 centimeter from the pivot, 25 plus 25 plus 50 centimeter from the pivot, on all these directions, and this one random over here. So first we need to know what is the equation to find torque. So this is the equation over here. T is equal to R multiplied by F multiplied by, this is an interesting one here, sin theta. Now you know why there is a degree over here, why there is an angle over here. It is because of this sin theta. That is basically unfortunate to be there, but it is helpful to find out this thing. So let us start by noting down the given information over here. We know that there are 4 forces given over here, as well as the various distance that is so separate. Actually, we mean, yes, start with the force 1. Force 1 over here, there is 10 newtons. For force 2, force 3, and force 4, hold on for a second, yep, there it is. Force 2, there is also 10 newtons. Force 3 also have 10 newtons. And force 4, this is the interesting one, it only got 5 newtons. Then we also have the force 3 degree. I'll just write as F3D is equal to 30 degrees angle. And then the various distance from the pivot. This, I'll just write dP, dP, and dP. Another dP. This is for 2, 3, and 4. Why there is no 1, you may ask? Well, the first one is directly on the pivots. You will understand soon. For this one, dP2 is 25 centimeter. dP3 is 25 plus 25 is equal to 50 centimeter. For dP4, it's 50 plus dP3, aka 50 centimeter, is equal to 100 centimeter. Though we may not going to be able to use this distance or radius from its current form. It's in centimeter. We're going to need it in meter. So we are going to add another equals 0.25 m, 0.5, and 1 mm. There we go. Now we can head into the question. What does it ask? It asks for the torques. T-O-R-Q-U-E-S, torques. And so we enter the answer. For the answer, we're going to head down with torque 1 first. We'll use, firstly, we can see that this one is 90 degrees. So basically, if it is 90 degrees, we don't actually need to use sin theta. So for torque 1, 2, and 4, we're only going to use TRF, no sin theta. It's going to only be used in torque 3. So torque 1, we are going to insert 0.25 multiplied by 10, yes, is equal to 0.25 can be changed into 1 over 4, aka 10 divided by 4, so we can just put it over here. It is 2, 8 minus 2, 0.5, and there you have it, 2.5 newtons. Hold on for a second, this is not for torque 1, this is, oh wait, yeah, it's not for torque 1. I'm so apologies over here, there may be a bit of a mistake. This is not torque 1, this is torque 2. Torque 1, because it is positioned directly on the pivot, it should only be 0. Multiplied by 10, and now you have 0 newtons. Torque 1 is valueless. This is the truth. Because everything multiplied by 0 or 0 multiplied by everything, the result will always be 0. Now we enter torque 2. Now this is where 0.25 should be implemented. Multiply it by yet another 10, and now you have, we just move, because it's multiplied, we just going to move the decimal 1 number forward. Now it is 2.5 newtons. Torque 3. Now this is where we are going to insert the sin over here. We're going to enter 0.5 multiplied by 10 multiplied by sin 30. Now sin 30, if you may not know, sin 30 is also equals to 1 over 2, aka it's another 0.5. So we're just going to insert 0.5 multiplied by another 0.5. It's basically 0.5 squared. It's just 0.25. We're going to meet this guy again. Multiplied by 10, the answer is torque 2. AKA it's another 2.5 newtons. Excellent. And now we enter torque 4. This is the last of her family. Torque 4 is the unique one. 5 newtons. Multiply it by a whole meter over there. 1. So the answer is obvious. The answer is 5 newtons. Because 5, anything multiplied by 1 is that anything again. And there you have it. Now we can write it down. T1, T2, T3, and T4. T1, T2, T3, T4, 0, 2.5, T2, and 5. Newton equals to 2.5 newtons, and Newton. There you have it. We already got what each torque is supposed to be, and now we just need to find which one applies to our answer right here. So because we know torque 1 is 0, we can narrow it down to just A and C. And we see at torque 2 is 2.5, torque 2 over C is 0. So we know exactly the answer is immediately A, because, well, as we can see, torque 2 is supposed to be 2.5, not 0 at all. Because, well, for it to be 0, it should be either directly on the pivot, or there should be no force at all applied to it. And there you have it. The answer to our question right here is A. Congratulations to everyone who watched this video, as well as myself as the one who worked on it. As well as special thanks to whoever made this equation right here, because now it is possible to make our work even easier than it already is. Now that I think of it, this equation is actually pretty old, but it's still useful to this day. And before any of if there is any degenerates that watch this video questioning, why do we even need to learn about this? Dude, if you somehow manage to become a construction worker, believe me, this is going to be very useful if you ever become a construction worker. Anyways, I suppose that's it about our video, our physics equation solving today. Thank you so much for watching this video of mine. Hope this is helpful. I'm sorry, I apologize if there is any mistake I may say or write down over here. Correction is open if you wish to correct any mistake that I actually made. And that's all from me. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.